It was the very first object to visit our solar system from outside our neighboring star group. It was moving so fast that it couldn't possibly be captured by the sun's gravity. This was the first time we had ever observed something coming from interstellar space, an object from beyond our solar system. For decades, people have been exploring space, typically sending probes to the farthest reaches of our solar system and beyond, hoping to find things our regular telescopes can't detect. The idea was that these objects existed out there, and it was only a matter of time before we discovered them. But the discovery of Oumuamua changed everything. Oumuamua, the incredible interstellar visitor, has been a hot topic for weeks. This object is believed to be part of another star system that was somehow ejected and traveled to us. Now, the James Webb Space Telescope has unveiled a real image of this cosmic anomaly, and it has revealed things no one expected. Let's take a closer look at this image and explore how Oumuamua's discovery has impacted the fields of science and space exploration. Oumuamua is a strange and fascinating object that suddenly appeared out of the depths of space, halting the world in its tracks when it was confirmed. Unlike anything we'd encountered before, this elongated, cigar-shaped object entered our solar system from a distant region beyond our own. Essentially, it was an interstellar traveler, passing through the vastness of space for a brief visit. Its bizarre shape, which resembles either a thin cigar or what some might describe as a cosmic needle, made it stand out from anything we had observed before. This remarkable discovery occurred on October 19, 2017, when the Pan-STARRS 1 telescope in Hawaii spotted the object in the night sky. It was a monumental event, as it marked the first time astronomers had identified an object from outside our solar system. Even more astonishing, the object was headed straight for Earth. The unexpected appearance of Oumuamua was one of the most significant astronomical events in recent history. It seemed to offer the key to unlocking the mysteries of our cosmic surroundings. That's why capturing a clear image of it became such a big deal. But a single picture is not where the story ends. Scientists have made plans to use the extraordinary James Webb Space Telescope to study interstellar objects as they pass through our solar system. One of the telescope's standout features is its ability to capture and analyze infrared light, making it an essential tool for this specific study. With its advanced high-resolution instruments and remarkable sensitivity, the Webb telescope is unmatched in its ability to observe objects that are too old, distant, or faint for other telescopes to detect. This incredible power allows scientists to delve deep into the nature of interstellar objects, revealing their chemical composition and unraveling their true nature. Studying these objects from Earth is incredibly difficult unless you can get a close, detailed look at them. The James Webb Space Telescope's advanced infrared cameras add an extra layer of precision, allowing it to capture intricate details and portray these mesmerizing celestial visitors as they move through our observational range. Even if you're not seeing a complete, unaltered image, the telescope can piece together hundreds, if not thousands, of images to create one ultra-detailed picture that showcases every tiny detail you'd ever want to observe. Its ability to capture the most elusive and subtle aspects of interstellar objects makes it an invaluable tool for researchers aiming to uncover the secrets hidden in the vastness of space. But this is just the beginning. The Webb telescope pushes the boundaries of exploration, enabling scientists to investigate the depths of space at scales and levels of brightness that were previously unimaginable. This opens up an entirely new realm of scientific inquiry, expanding our knowledge and understanding of the universe. This is why scientists chose the James Webb Space Telescope over the Pan-STARRS 1 telescope for further research. That doesn't mean the Pan-STARRS 1 telescope isn't a great instrument. In fact, it is unique in its own right. Located atop the majestic Haleakala volcano on the island of Maui, Hawaii, Pan-STARRS 1 plays a crucial role in the Pan-STARRS project, a collaboration between respected institutions such as the University of Hawaii Institute for Astronomy, MIT Lincoln Laboratory, the Maui High Performance Computing Center, and Science Applications International Corporation. The Pan-STARRS 1 telescope is designed for wide-field astronomical imaging, offering a comprehensive view of space. Its primary mission is to conduct extensive surveys of the night sky, capturing images of distant galaxies, nebulae, comets, asteroids, and other celestial objects. To handle the vast amount of data collected during these surveys, The Pan-STARRS 1 telescope relies on its cutting-edge PS1 image processing pipeline. This advanced software automatically processes and analyzes the enormous quantities of observational data, extracting valuable insights and allowing astronomers to make groundbreaking discoveries. The power of advanced algorithms and computational techniques plays a key role in uncovering the mysteries hidden within the millions of images captured by Pan-STARRS 1. One of the telescope's most impressive contributions is its involvement in the Pan-STARRS Near-Earth Object Survey, an ambitious project aimed at systematically scanning the sky to identify near-Earth objects that may pose a potential threat to our planet. This is how Pan-STARRS 1 discovered Oumuamua in the first place. Although the telescope was not specifically looking for this object, it happened to spot it while conducting its usual operations. Initially, scientists thought it was a typical asteroid heading toward Earth, which is a common assumption when an unidentified space object is detected. However, upon closer inspection and analysis of the gathered data, it became clear that this mysterious interstellar traveler was unlike any normal asteroid. Its sudden change in direction raised intriguing questions about its true nature. And this is where things took a surprising turn. The situation became increasingly urgent due to the rapid movement of Oumuamua through our solar system. Time was of the essence, and scientists faced an overwhelming challenge. They had only 11 days to gather as much data as possible about this unusual object before it drifted too far to study. With each passing moment, the window of opportunity to collect vital information grew smaller, heightening the pressure. Any delay could jeopardize their ability to understand this unique phenomenon. When it comes to making the most of time, NASA is the expert. So, they turned to the powerful tools at their disposal to reveal more about Oumuamua. The European Southern Observatory's Very Large Telescope in Chile played a pivotal role, tasked with accurately measuring the object's size, tracking its orbit, and examining its color and brightness. Every detail of the object's surface and composition was crucial, given that this was an object no one had ever imagined before. It was essential to capture as much data as possible, as once Oumuamua left the solar system, there might not be another chance to gather such information. The goal was clear: use every available instrument and expertise to maximize the data collected, and study it in depth afterward. However, as scientists delved deeper into the data, it became apparent that gaining clarity about Oumuamua was more complicated than anticipated. Instead of resolving the mystery, the more they learned, the more questions arose. Typically, when we think of a space rock, whether it's an asteroid or a comet, we imagine a round or roughly spherical object. This assumption is rooted in the fact that most celestial bodies tend to adopt spherical shapes due to gravitational forces. The atoms within these bodies are pulled toward a central gravitational source, like the Sun, which helps maintain a roughly round shape. However, Oumuamua defied this norm with its elongated cigar-like shape, unlike any other known object in our solar system. It measured about 200 meters in length, with its length being 10 times greater than its width, an unusual aspect considering the vast distances of our solar system. Adding to the intrigue, Oumuamua exhibited a distinctive reddish hue, often seen in objects located in the outer reaches of our solar system, typically due to surrounding dust. But there was no sign of dust on Oumuamua, as it appeared to be made entirely of rock and metals, with no traces of water, ice, or other typical ingredients found in celestial bodies. Speed was another surprising factor. Despite its size, Oumuamua sped through the solar system at an astonishing 196,000 miles per hour, and its velocity wasn't constant. It fluctuated during its journey, suggesting an additional, unexplained force was acting on it. This raised further questions. Was Oumuamua being influenced by an unknown substance, or was it being guided by something within? The first crucial question scientists needed to answer was where it had come from. Through careful analysis of its speed and trajectory, they traced Oumuamua's origins back to the star Vega, the brightest star in the Lyra constellation. However, due to the vast distances involved, it was clear that Oumuamua had been traveling near Vega for at least 300,000 years, even though it was moving at an average speed of 59,000 miles per hour. The challenge here was that Vega might not have even been in that location when Oumuamua passed by, as the star's position could have changed over such long timescales. One intriguing hypothesis suggested that Oumuamua could be a fragment of a larger celestial body, shattered by gravitational forces during a close encounter with its home star. This theory might explain some of its peculiarities, though the idea remains speculative. Another study published in Nature Astronomy proposed a more detailed model explaining how objects like Oumuamua might form through processes similar to those shaping bodies within our own solar system. The research suggests that Oumuamua could have formed through mechanisms that align with its unusual characteristics, providing insight into the formation of interstellar objects. However, not all scientists agreed with these explanations. A study by Harvard astronomer Avi Loeb challenged the idea that Oumuamua could be a nitrogen iceberg from another solar system. Loeb's research suggested that Oumuamua might be a fragment of a planetesimal similar to the comets in our solar system, broadening the range of potential explanations for its origins. Despite these hypotheses, there's still no definitive answer. What's certain, however, is that Oumuamua passed beyond Earth's orbit on October 14, 2017, coming within about 24 million kilometers of our planet. Though it went unnoticed during its encounter with Earth, it continued on its journey through the solar system, heading toward the distant Pegasus constellation. As it moved farther from Earth, its speed increased, and it quickly became too difficult to track. Its unpredictable velocity made monitoring its movement a significant challenge. As Oumuamua ventured deeper into space, it eventually vanished from view. The James Webb Space Telescope, however, may hold the key to uncovering more about this mysterious object. Given that the telescope has successfully gathered data from objects 28 billion light-years away, it could potentially provide more information about Oumuamua, which is located a mere 700 light-years from Earth. This advanced instrument may offer the crucial insights that have eluded scientists so far.